Hi, so this is a worksheet that gives you practice finding missing sides of a triangle using the Pythagorean theorem, and then simplifying the radical if necessary, and then also finding the sine, cosine, and tangent ratios for a given angle. So we're going to start by looking at problem number 1. And the first thing that we need to do in order to find the sine, cosine, and tangent ratios is to find all three sides. So we have two of the side measures, now we just need to find x. So we're going to do that by using Pythagorean theorem. Now, Pythagorean theorem, normally we're used to using a squared plus b squared equals c squared, but we want to get used to using c squared equals a squared plus b squared, only because it's easier when we're using the converse to classify triangles to put c squared first. So then I'm just going to fill in my values. In this case, I have x squared is equal to 10 squared plus 12 squared. It doesn't matter which order 10 and 12 are in because a and b can be switched, but the c value has to be x. And then I'm just going to simplify. I get x squared equals 100 plus 144. And then I get x squared equals 244. And then to get rid of the squared here, I take the square root of both sides. So I get x equals square root of 244. Now we have to look and see if we can simplify this. My first guess is maybe there's a 16 inside of 244. Not sure if there is, so I'm just going to do 244 divided by 16 because 16 is a perfect square, and I get 15.25. So 16 doesn't go into that. This is not going to be divisible by 9, so let's try 4. 244 divided by 4, and you get 61. So if this breaks down into 4 and 61, 61 doesn't break down any further than that. So basically this just becomes the square root of 4 times the square root of 61. 4 is a perfect square, so we get that x is equal to the square root of 4, which is 2, times the square root of 61. So 2 radical 61. Okay, so I'm going to fill that in here. 2 square root of 61. Now the next part of this is to find the sine, cosine, and tangent ratios for angle A. So for some reason angle A got erased over here, but it should be here. That's angle A. This was angle C. So the first thing you're going to do is circle your angle and then label your triangle based on that angle. So because this is your angle that we're concerned with, that means that 12 has to be the opposite side. 10 has to be the adjacent side, so label that A. And then 2 times the square root of 61 has to be the hypotenuse. So in order to find the sine of A, this is just a ratio. It's something over something. So sine, if we write SOHCAHTOA up here, SOHCAHTOA, this helps us remember what the sine ratio is equal to. So we know that sine is equal to opposite over hypotenuse. So opposite is 12. Hypotenuse is 2 times the square root of 61. So this is going to simplify. Let's just at least simplify the 12 over 2. That's going to simplify to 6 on top, 1 on the bottom, so we don't have to write that, over square root of 61. Now we have this radical in the denominator, which in math, we don't like that. So here we have to do what's called rationalizing the denominator. So in order to do that, we multiply by the square root of 61 over the square root of 61. The reason why we're able to do this is because square root of 61 over square root of 61 is just 1. So you're allowed to multiply anything by 1. We call that the radical 1. Get it? Anyway, so now we multiply straight across. We get 6 times the square root of 61 over, and then the square root of 61 times the square root of 61 is the square root of 61 squared. So what happens is the square root cancels with the squared because they're inverse operations of each other. So this just becomes 61 on the bottom. So again, a radical times itself gets rid of the radical and you just have that number in the denominator, so 61. Okay, so that's the sine of A. Now cosine of A is going to be equal to adjacent over hypotenuse, so that's 10 over 2 root 61, which equals 5 over the square root of 61. Then we rationalize the denominator, same way we did before. We get 5 times the square root of 61 over 61. And then last but not least, tangent of A. We're always taking tangent, cosine, and sine of an angle. So tangent of A is equal to opposite, which is 12, over adjacent, which is 10. So this one's easy, because that's just going to simplify to 6 over 5. And now we have all three ratios, and we are done.